Next is question number 43, which says that if volume of a parallelepiped formed by three coterminous vectors A, B and C is 3 centimeter cube, then the volume of the tetrahedron formed by three coterminous vectors P, Q and R in centimeter cube, where P is equal to B cross C, Q is equal to 5 times C cross A and R is equal to 2 times A cross B is. So it has been given that scalar triple product of ABC is equal to 3. So we have to find volume of the tetrahedron, that is 1 by 6 times P, Q and R. This is what we have to find, which is equal to 1 by 6 P dot Q cross R can be written as 5 into C cross A cross 2 times A cross B. That is equal to 1 by 6 into P vector into 10 dot scalar triple product of CAB into A. Now CAB is equal to scalar triple product of ABC, that is 3 times A vector, and the other term will get cancelled. So this is equal to 5 multiplied with P dot A vector, that is equal to 5 into P vector, that is B cross C dot A, that is again 3. So this is equal to 15. So answer of this question is 15. Next is question number 44, which says that if AI, BI, where I is equal to 1, 2, 3, 4 are the ordered pairs of integers satisfying tan inverse AI minus tan inverse BI is equal to sine inverse 1 by root 10, and A1 is less than A2 is less than A3 is less than A4, then we have to find modulus of B1 plus B3. Now we know the formula of tan inverse A minus tan inverse B, that can be written equal to tan inverse A minus B upon 1 plus AB, and the value of sine inverse 1 by root tan, that can be written as tan inverse 1 by 3. Now which means that A minus B upon 1 plus AB will be equal to 1 by 3 for AB greater than minus 1. So we have to find the solution of this equation. Let's write it in other form. That is A plus 3 into B minus 3 is equal to minus 10. Right? Now its solutions can be found. These are the values of A plus 3 and B minus 3 which are possible, right? This is 10, so this is minus 1. This is minus 10, so this is 1. This is 5, this is minus 2. This is minus 5, so this is 2. This is 2, minus 5, minus 2, 5, minus 1, 10, 1, minus 10. So these are the possible values of A and B. From these values, we have to find those values for which AB is greater than minus 1. So those values are minus 2, minus 7, minus 1, minus 2, 2, 1 and 7, 2. These are the four values, as it have been given that A1 is less than A2 is less than A3 is less than A4. So the values of A1, A2, A3, A4 are fixed. So the value of B1 plus B3, that will be minus 7 plus 1 whole modulus. So the answer will be 6. Next, question number 45, which says that let Cn denotes a circle of radius n centimeters and center at origin for n belonging to n. A particle moves n centimeters in anti-clockwise direction on circle Cn. After completing its motion on Cn, the particle moves to Cn plus 1 radially outwards. The motion of particle continues in this manner if the particle starts from 1, 0. Then the distance traveled by the particle when it just crosses the positive x-axis for the first time is A pi minus b units, then A plus b is. So the diagram will be something like this. Let us say this is the first circle. This is the second circle, this is the third circle, and so on, right? So the particle starts at 1, 0. Radius of first circle is 1. So it moves here 1 unit. then it moves radially outwards. This is also 1. Now here it will go 2 units. Then it will go outward 1. Then here it will go 3 unit and so on. Here we want that it should cover 2 pi angle, this one, right? Now 2 pi in radians will lie between 6 to 7. Now in first circle, as this is 1 and its radius is also 1, so the angle theta that have been covered by it is 1 radian. Similarly, in second circle also, the radius and length that have been covered both are 2. So the angle that have been covered is again 1 radian. So after 6 circles, when it goes to 7th circle, it have already covered 6 radians. Now it have to cover angle of 2 pi minus 6 when it is on 7th circle. So the distance that have been covered by it is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus the radial distance, that is 1 into 6, that is 6, plus the distance, this one. Now this distance, let us say S, will be equal to, the radius is 7 and theta is 2 pi minus 6. So S will be equal to 7 times 2 pi minus 6. So this is the distance that have been covered by it. So it will be equal to 14 pi minus 15, which means that value of A is 14 and value of B is 15. So value of A plus B is 29. So answer of this question is 29. Next is question number 46, in which we have to find limit L1 and L2. Then we have to find 4 upon L1 plus 1 upon L2. Now let's firstly find L1. That will be equal to limit n tending to infinity, multiplication from r equal to 2 to n. A cube minus b cube can be written as a minus b into a square plus b square plus ab, and similarly in the denominator we will write it as plus 1 minus r, right? Now we will take two series here, that is this one and this one. We will take it separately, so that will be equal to limit n tending to infinity when r is 2, so it will be 1 upon 3, multiplied with when r is 3 it will be 2 upon 4, and so on up till when r is n, that is n minus 1 upon n plus 1. Now next, here putting r equal to 2, we will get 3 plus 4, that is 7, divided by 4 plus 1 minus 2, that is 3, multiplied with putting r equal to 3, we will get 9 plus 1, that is 10 plus 3, that is 13, divided by 9 plus 1, that is 10, minus 3, that is 7, and so on. So we will see that these two get cancelled. So the terms that will be left are 1 into 2 divided by n into n plus 1 from first series, and from second series we will get n square plus n plus 1 upon 3. And here we have to find the limit n tending to infinity. So this will be equal to, dividing in the numerator and denominator by n square, we will get it equal to 2 by 3. So value of L1 is 2 by 3. Now we have to find L2. Now this can be written as limit n tending to infinity, summation r going from 1 to n, r multiplied with n minus r plus 1, multiplied with n minus r plus 2, and in the numerator we will have 2 into n raised to the power 4. Now from these we can find only those terms whose multiplication is of 3 degree, because when we apply summation in the numerator, then it will become a 4 degree term, which when cancelled with denominator will give us answer, because in any other case that term will give us limit equal to 0. right? So this can directly be written equal to limit n tending to infinity summation r equal to 1 to n 3-degree terms, that will be r cube plus n square r minus 2n r square, and in the denominator we have 2 times n raised to the power 4. So solving this, we will get it equal to 1 by 2 times 1 by 2 plus 1 by 4 minus 2 by 3, that is equal to 1 by 24. So the required value will be equal to 4 divided by 2 by 3, that is 6, plus 1 by L2, that is 24, that is equal to 30. So the answer of this question will be 30. Next is question number 47, which says that a differentiable function fx defined in 1 to infinity satisfies the equation x into x square minus 1 into f dash x plus 2x square minus 1 into fx minus x into under root x square minus 1 is equal to 0, and f of root 2 is equal to 1 by root 2 if area of the region bounded by y equal to fx, x equal to 2, x equal to 7 and x-axis is a, then we have to find greatest integer of a. Basically, we have to find the function fx here. So, it has been given that dy by dx plus 2x square minus 1 into y divided by x into x square minus 1 is equal to 1 divided by root of x square minus 1. I have put fx equal to y here. So, it is a linear differential equation where integrating factor is equal to e raised to the power integration of 2x square minus 1 divided by x into x square minus 1 into dx. So this can be written equal to e raised to the power, taking 2 common, we will get x square minus half in the numerator, that can be written as x square minus 1 plus half divided by x into x square minus 1 dx. So this is equal to e raised to the power 2 times integration of 1 by x, that is ln x, plus 1 by 2 will be cancelled with 2. So we have integration of dx divided by x into x square minus 1. Here let us take x square minus 1 equal to t. So we will get 2x dx equal to dt. So we will get e raised to the power 2 times ln x plus integral dx will be written as dt divided by 2 x square, that will be t plus 1 into t. So its integral will be equal to e raised to the power 2 into ln x plus half into ln of t upon t plus 1, that is x square minus 1 upon x square. So this is equal to x square into x square minus 1 by x square whole raised to the power 1 by 2. So this is equal to x into under root of x square minus 1. So let's now find the solution of the given equation, that will be y into integrating factor, that is x into under root of x square minus 1 is equal to integral of x into dx, that is x square by 2 plus constant. Now here let's put x equal to root 2, so y will be 1 by root 2. So it will be 1 equal to 1 plus constant, which means that value of c is 0. So y is equal to x upon 2 into under root x square minus 1. Now we have to find the area bounded by y equal to fx, x equal to 2, x equal to 7. So that will be integral 2 to 7 x upon 2 x square minus 1 under root into dx. Now here let's take x square minus 1 equal to t. So we will get 2x dx equal to dt, and the integral will go from 3 up till 48 dt upon 4, and it will be t raised to the power 1 by 2. So this is equal to t raised to the power 1 by 2 divided by 2, and it will go from 3 up till 48. So this is equal to root 48 minus root 3 whole divided by 2. So that is equal to 4 root 3 minus root 3, that is 3 root 3 divided by 2. So its greatest integer will be equal to 2. So answer of this question is 2. Next is question number 48, which says that let C1 is y equal to 4x, C2 is y equal to sin x, and C3 is y equal to fx be three curves passing through the origin O and defined in 0 to pi by 2. From a point P on C2, lines parallel to x and y axis meet at C1 and C3 at Q and R respectively as shown in the figure, such that areas of curved regions OPQ and OPR are equal for all positions of point P. So we have to find the value of f of pi by 4, right? Now here let us take the point P. As the curve C2 is y equal to sin x, so the point that can be taken on P is t comma sin t. And the curve C1, that is y equal to 4x, and C3 is y equal to fx. Now these two areas are given to be equal, so we can say that integration from 0 to t sin x minus fx into dx, that is the lower area, is equal to integral from 0 to sin t y equal to sin x, that can be written as sin inverse y minus y by 4 into dy. These are the two areas. Now here using Newton-Leibniz theorem, so let's differentiate it. We will get sin t minus f of t is equal to sin inverse sin t, that is t, into differentiation of sin t, that is cos t, minus sin t upon 4 into cos t. So from here we can say that f of t is equal to sin t minus t cos t plus sin 2t upon 8. Now here putting t equal to pi by 4, we will get f of pi by 4 is equal to 1 by root 2 minus pi by 4 root 2 plus 1 by 8. Now comparing it with the given equation, we can say that the value of a is equal to 8 and the value of b is equal to 4. So we can say that the value of a plus b will be equal to 12. So this is our answer. Next is question number 49, which says that let E is an ellipse whose axes are along, coordinate axis and distance between foci is 8 units. At any point P on E, tangent and normal are drawn which cut the coordinate axis at A, B and A dash, B dash respectively. If delta 1 and delta 2 be the areas of triangles OAB and OA dash B dash, then we have to find the value of delta 1 into delta 2. Let us say this is an ellipse and here is a point P on it. This is a tangent and this is the normal. So the point P is A cos theta, comma B sin theta, as we have taken ellipse as x square upon a square plus y square upon b square equal to 1. Now the equation of tangent x by a cos theta plus y by b sin theta equal to 1, and the equation of normal will be ax upon cos theta minus by upon sin theta equal to a square minus b square. So we can find the points a, b, a dash and b dash. The point a will be putting y equal to 0, a by cos theta, comma 0, and point B will be putting x equal to 0, we will get b upon sin theta. Similarly, point A dash can be found by putting y equal to 0, we will get a square minus b square into cos theta upon a, comma 0, and b dash will be 0, comma a square minus b square into sin theta upon minus b. Now we have to find delta 1 and delta 2. delta 1 will be equal to half into AB divided by cos theta sin theta. Similarly, delta 2 will be equal to half into A square minus B square whole square into cos theta into sin theta divided by AB, because we have to take its magnitude. So delta 1 into delta 2, that will be equal to AB will get cancelled and cos theta sin theta will get cancelled. So it is A square minus B square whole square divided by 4. Now we know that E square is equal to 1 minus B square upon A square. So A square E square is equal to A square minus B square. So here putting the value, we will get it equal to AE whole raised to the power 4 divided by 4. Now it has been given that distance between foci is 8, which means that 2AE is equal to 8, that is AE is equal to 4, that is 4 raised to the power 4 upon 4, that is 4 cube, that is 64. So answer of this question will be 64. Next is question number 50, a very simple question from matrices. Here it has been given that A is a symmetric matrix and B is a skew symmetric matrix, such that 2A minus B is given to be equal to 3 cross 3 matrix. We have to find the determinant of 2A. Now, if we take transpose on both sides of equation 1, we will get 2 times. A transpose is equal to A minus B transpose will be equal to minus B. So it will be plus B, and this is equal to 1, 2, minus 1, 2, 3, 1, 4, 2, 2. As we are concerned with determinant of 2A, so let's add both the equations. So we will get 4A equal to 2, 4, 3, 4, 6, 3, 3, 3 and 4. Now taking determinant on both sides, determinant of 4A will be equal to 2 times 24 minus 9 plus 4 times 9 minus 16 plus 3 times 12 minus 18. So that will be equal to minus 16. Now here taking 2 outside from the determinant, we can write 2 raised to the power 3 into determinant of 2A is equal to minus 16, which means that determinant of 2A is equal to minus 2. So the absolute value of determinant of 2A will be 2. So answer of this question is